Oh, hello. Welcome to my laboratory. My name is Professor Mac, and today I'm going to be talking about Newton's first law of motion. This is one of 3 laws which Sir Isaac Newton published in 1687. The laws explain the interaction of forces and objects, and the way in which the motion of an object is affected by force. So what about the first law? Well, the best way to understand this is for us to do an experiment. Okay, well, here is our experimental setup. We have a block of wood here representing our object, and as you can see, it is resting on a very smooth surface, which is so smooth we can assume that it provides no resistance to the block moving on it. So what about Newton's first law? Well, it states that an object, such as our block here, will remain in its current state of rest, in other words not moving, unless acted upon by an unbalanced force. So let's look at our block. You can see it's not moving, and it continues to stay that way. So Newton's first law would suggest that the forces on the block must be in balance, otherwise it would start moving. So let's have a look at the forces on the block. We represent the forces by arrows, which show the direction of the force and also the size of the force. The longer the arrow, the larger the force. The first force on the object we consider is from gravity, and it acts vertically down. Looking around the object, we can see it is in contact with the surface of the table. Since we have used Newton's first law to conclude that the forces must be in balance, it follows that the force from the table onto the block must be upwards and equal in size to the gravity force. This means the forces in the vertical direction are in balance, and the block continues to remain stationary in the vertical direction. In the horizontal direction, there are no forces, and so the block continues to remain stationary in the horizontal direction. So what if we introduce a horizontal force? What do you think will happen? Well, we can do that by using this piston I have set up next to the block. When I push the button for the piston to move, it will push the block. Let's see what happens. Well, we can see that the block changed from being stationary to moving horizontally, and Newton's first law tells us that this is because there was an unbalanced force on the block. Let's run a replay and look at the forces on the block. We can stop the action just as the piston contacts the block. Now you can see we have the vertical forces as before, and also a horizontal force from the piston. The vertical forces are still in balance, so there is no change in the vertical motion of the block. However, the unbalanced piston force pushes the block horizontally, changing the state of the block from being at rest to it moving horizontally, just as we would predict using Newton's first law. As the block continues to move horizontally, you can see that the vertical forces are still the same and in balance. But what about the horizontal forces? Well, there is no piston force, and the highly polished surface provides no resistance to the motion of the block, and therefore there are no horizontal forces acting on the block. So all forces are in balance, resulting in no change in the motion of the block. It is still moving, but it doesn't change with time. It is constant motion. This observation, which may at first seem surprising, is consistent with the second part of Newton's first law, which states that an object will continue in its state of uniform motion in a straight line unless acted upon by an unbalanced force. So there we have Newton's first law of motion. In summary, we observed during our experiment that an object will continue in its state of rest unless acted upon by an unbalanced force. and we also observed that it will continue in its state of uniform motion in a straight line when all forces are in balance. So here is a question for you. What if the block moved on a surface which resisted the motion of the block? What do you think would happen? Can you draw a diagram of the forces on the block? Well, for some help in working out the answer and to see what else I'm doing, why don't you come and visit me at my website, learnwithmac.com. Well, thank you very much for joining me today, and I look forward to you visiting again. From me, Professor Mac, until next time, all the best. Bye.